Okay, everybody, I think we'll make a wee start. As I think most of you know, I'm Andrew Stewart. I'm Professor of Cognitive Science, Head of the Department of Computer Science. It's really fantastic today to welcome to our university Missy Cummings for a special research seminar. Missy received her undergraduate degree in mathematics from the US Naval Academy, her master's in space systems engineering from the Naval Postgraduate School, and her Ph.D. in systems engineering from the University of Virginia in 2004. Missy is a naval officer or was a naval officer and military pilot from 1988 to 1999, and is one of the US Navy's first female fighter pilots. Missy is currently professor in the George Mason University College of Engineering and Computing, and directs the Mason Responsible AI program, as well as the Mason Autonomy and Robotics Center. She's a fellow of the American Institute of Aeronautics and Astronautics and member of the Virginia Academy for Science and Engineering and Mathematics, with her research interests spanning the application of AI in safety-critical systems, assured autonomy, human systems engineering, and the ethical and social impact of technology. And Missy is here today to tell us all about what autonomous vehicle failures can tell us about engineering safety-critical AI. Okay. Over to you, Missy. Thank you.
So I just want to, in pure academic form, Andrew just read the title of the presentation I was going to give, and I changed it at the last second because I just got out of a meeting where the question is, how do you go from being a professor, teaching students, writing papers, going to conferences, et cetera, to actually affecting public policy? So I thought, it's a very similar talk, but I thought we'd go down this path instead. Yeah, and so, hang on some of the, all right, so how does this all work? Yes, I flew F-18 fighters. That is a whole nother set of stories, best told around the bar. I can entertain you for hours on just those stories. Then I went back to school, got my Ph.D., ended up being, for the first 10 years of my academic career, at one point, I was known as the queen of drones. That is because I was one of the very first people to start doing research. Little first note, first lesson learned, try to always be at the beginning of a wave, not at the end of the wave, right? The problem is you don't even know if you're on a wave yet, right? So sometimes you only know that in retrospection. But at that point in time, then this next picture is me sitting next to, at the time, which is the chairman of the FAA. He was the FAA administrator. I was there. I had been invited to be at this congressional testimony because I was jumping up and down saying that the FAA were a bunch of losers. The people who've met with me the last couple of days, I do have this tendency. If I don't like you, if you make me mad, I jump up and down and I say, you don't know what you're doing, and you need to let drones come into the national airspace. And then, surprisingly, somebody listened, and they did. And then drones were commercialized in the United States. And then I'm like, well, now I need to find a new really good set of research questions. So then I moved into self-driving cars. This is me doing some early research in 2012, which is looking at what would eventually become something like autopilot, cars that do lateral and longitudinal changes. And of course, we were looking at the human component, and this guy crashes, and he crashed. And in the middle of the crash, you can see he pulls up. What is that? A cell phone. Oh, yes. This is foreshadowing to what we all know to be true today, is that the phone has made you a terrible driver. Then I go over into invited back. I was so entertaining the first time at the Senate Commerce Committee that they invited me to come back. So I wowed them again, and this time I knew what I was doing. The first time I had no idea what I was doing. You can see me, I look kind of really paying attention. The second time I knew what was happening, and I was able to get the sound bites in where I was. I said, I closed the conference, I jumped in at the last minute, and I'm like, if you don't do something about this, someone is going to die. And then 3 weeks later, someone did die. And then there's nothing like telling Congress that somebody's going to die, then your prediction comes true, then that kind of helps accelerate you into the sphere of, oh, she might know what she's talking about. Then that has led to me to go after several other windmills, not the least of which is the UK government. It's driving me crazy because they keep saying things that are just stupid about AI. Our own government, the US government, also says stupid things. But look, Trump is out of control. I can't do anything about that right now, so I'm attacking your government instead. Eventually, I will go back to attacking my own government when I'm not afraid that they're going to take me off in an ICE van. Okay, so what is safety critical AI? It's really AI that shows up in all these places. It shows up in cars, drones, surgical medical devices. This is a flying taxi. It's a drone that you can order by your phone that theoretically is going to come and pick you up. It's in development right now. Don't hold your breath. Not coming anytime soon. I'll be dead before this thing is ever commercialized, but you might see it. I've worked with Amazon Robotics, so manufacturing is a big one, and it shows up also. One of the things that people don't realize is that there is no such thing as a real self-driving car. No car drives by itself. This is a picture of a remote driving center in China. This is actually how China is doing all of its self-driving. It's basically video gaming it and pretending to be real AI. I mean, there is some AI for sure, but there's a human backstop, and that's going to be the thing that we're going to see over and over again, that wherever you have neural net-based AI, you're going to need a human backstop, especially in safety-critical systems. Now, I worked for about a little over a year for the Biden administration looking at self-driving car accidents, trying to figure out what's really happening with them and what is that telling us about the state of AI in the world of transportation. So I wrote this paper, which you can go retrieve for free on the internet right now. We found out that in this data set, there were basically 5 different kinds of accidents. The first one I'll talk about is the safety driver accident. When you're doing self-driving, when there's a new software update, humans will actually get in the car, make sure that the car is doing well enough, and it turns out that after the autonomy is disabled and the car drives either to or from the area that they're testing, they're still humans, they still have accidents, right? But it's very low. On average, it's less than 10%. The middle category of planning is the second least accident area. And the companies that we're looking at, by the way, are Cruise. They no longer operate for a reason I will tell you in a second. Waymo, who is coming to a town near you, and Zoox, they do autonomous shuttles, not coming to a town near you anytime soon, but they say they are. These are multi-people movers, whereas Waymos are doing passenger cars. So in this picture right now, I know that to you, the middle picture looks normal. It looks like a car driving down what we would call the right side of the road, but if you've been in the US, hopefully you recognize, and you can see the cars behind it, it is actually driving on the wrong side of the road. Why? Because it had been taking a left onto this road, and you can see that in the turn lane right next to it, the turn lane is totally just gobsmacked. And the car, who among us just wants to make our own way on the road? We just want to, I just want to do my own thing. There's too much traffic for me, and the car just turned for no reason into traffic, which it theoretically has been programmed that what the rules are, and it decided to ignore the rules that day and just go, we're not really sure why this happened. Google's not forthcoming with why this happened, but this happens all the time, it turns out. These cars just start making up their own rules. And this is a problem, right? Because this is highly unpredictable. And yes, it was okay. This is in Arizona, so it's a bright, sunny day, but that's really not going to be it's not going to lead to predictable operations. The third category, least category, is perception. It turns out their accidents are roughly around 10%. This is when the car doesn't see something in front of it when it should see something in front of it. This was the pictures from a very dramatic crash, a banner crash. This was a Tesla crash. Anybody drive a Tesla? in this room? Or wants to admit it? Yeah, yeah. You can't have full self-driving in this country. There's a reason for that, because it doesn't work, and that is why it is under investigation in the United States. And this wasn't even full self-driving. This was just regular autopilot. The car was going down a highway, and a tractor, it was dusk, so it was just beginning to be light, and a tractor trailer pulled in front of it to do a left-hand turn. And it was viewable by a human. A regular human paying attention would have seen it and braked for it. And indeed, in truckers in America, they do this all the time. They'll pull out thinking you will brake. He didn't brake, ever. Underran the truck. He was beheaded and done, right? Never saw what was happening. Ouch, bad. I'd like to tell you this was the first time it happened. This was the second time it's happened. It's happened 2 more times that I know of since then. So this is a failure mode that continues to be a failure mode and purely computer vision driven. This is actually why Teslas will never be actual self-driving cars, because they can't. Computer vision is a deeply flawed technology. Now, I'm going to talk about struck from behind next, because even though the highest category, I think now that we're on the Tesla theme, I can tell you what happened in this one too. Struck from behind means that you're driving along and somebody hits you from behind. It turns out that self-driving cars, this is happening 2 times more often than for regular human-driven cars. So it's a problem. It's a problem because I just told you about Teslas, and all self-driving cars have this problem. Sometimes they don't see what is in front of them. They also have false positive problems. They don't see, they see something that is not there, meaning a real hallucination. So in these cases, this was a case of Tesla was leading a pack of cars through the Bay Bridge Tunnel in San Francisco, saw something, but was nothing, and it went from 65 miles an hour to 0 in a second. You know, it's a very hard braking action. It caught everybody else by surprise, and 8 other cars plowed in behind it. 1, 2, 3, 4, no. Nobody died this day, but people have died. They are also under investigation for phantom braking. All self-driving cars have phantom braking problems. All neural nets have hallucination problems, whether they are in surgical devices, cars, planes, whatever. Large language models, neural nets hallucinate. This is just an unavoidable factor of probabilistic reasoning, that you just can never get a 100% purely predictive algorithm, and we're going to have to figure out what to do about that before these things become, especially at high speeds, become commonplace. The last accident is the cruise, which is UAO. UAO means unexpected actions by others. This was a case where a woman was jaywalking in San Francisco. She actually jaywalked in front of the Waymo and got hit by another human-driven car on the other side. So she made it in front of the Waymo, was hit by another car, and then knocked into the path of the Waymo. And the Waymo did an emergency braking maneuver, actually quite good, and it hit her, but just a little bit. And she fell underneath the front of the car. Had everything stopped there, she probably would have gotten up and walked away. But the one thing you should remember from this talk is neural nets do not know, do not think, do not understand, do not actually reason. They may make probabilistic associations. That is not the same as reasoning. They cannot think, they cannot imagine. This is true for every single large language model. They don't know anything. She falls under the car. She's gone from the camera views. It assumes that she magically, in the world of Harry Potter, she apparated somewhere else. And then it just decided to do a pullover maneuver, pulled up about 20 feet at 7 miles an hour over and off to the right. And it's hard to see in this picture, but she's under the back left tire. And they had to eventually lift the car off of her. She lived. She was in the hospital for a year. Crew settled that case very quietly. And then also, because they lied to the US regulators about it, they lost their license to operate. They think they're coming back. They're going to try to make a comeback. We'll see about this. But on many, many, cases, it's just kind of badness all around. But the one thing you might be asking yourself is, wow, this computer vision system's not really good, are they? Well, we'll talk a little bit more about that. This is about some research that I've done personally myself to try to get at this problem. Like computer vision, why is it so terrible? On the best day in the lab, it's about 97% accurate. And that's in the lab under carefully controlled conditions. And so if we're talking about, if you think about it, if 3% of times a car sees something and it's not right, that's not good, right? So, and the failure case is probably much higher. So we wanted to look at, one of the things I noticed when I was working for Amazon Robotics is that Amazon, like most companies, has warehouses of people in India who do labeling. They actually, what they do is we get a bunch of images and then you draw edges around everything in the image and you label that and then you push that through a computer vision system, and that's how computer vision systems learn. This is called supervised learning. The world is labeled for them. The system learns all the edges, theoretically, that a shape could take on, and then that's how it learns what a thing is. So I am showing you here, there's a couple of different ways you can have people label. You can have a box drawn around them and say, this is a car. Or you can actually do the little dots in the second image and show this is a car. Now, the funny thing is that I used Gen AI to, like DALL-E, to generate the image. Do you see, I said I wanted DALL-E to give me traffic, crowded traffic on a street. And what did it do? Look at that truck in the background. Like, gang. The fact that anybody thinks that AI is both sentient, deserves personhood, is about to kill us all. I mean, we can't even get these systems to actually understand the right way cars should point down a road. Okay, now, and this is a student of mine that just graduated. This is Ben Bauschwitz's research. So the idea is we looked at different labeling techniques. So I'm showing you a set of raw images here, and this is what is called ground truth. And by the way, ground truth is careful labeling, carefully drawing those lines around. Now, is it really ground truth? It's not really ground truth in any sense of true, but it's just like really careful labeling. Then we put a polygon around it. We used an outline, and we used the paintbrush. And the reason we use these is to show that, because all of these tools are available to those warehouses of people doing labeling in India, where it's not just in India and China, wherever they're doing this. And, you can start to see, you're like, whoa, if I look at ground truth, using the polygon mask is kind of terrible. And then by the time I get to paint, wow, it's just a bunch of blobs. How is it possible that the system is learning this? Well, I'm telling you, this is legitimately how the world works right now. So then we did all the training, then we pushed these images through 5 different neural nets. And we just picked these neural nets because they are commonly cited in the literature for doing computer vision for vehicles of sizes. So what we also did is, and you can see on the vertical, we actually had a lot of different experimental conditions. We had a bunch of people on Mechanical Turk. We had a control condition, ground truth. We paid them per object because we wanted to see if we incentivized people through money, through the objects they had to label, that they would be okay. They were, to the control people, they were just paid per image, not per object. Then we had time limit. We put a timer on them, then polygon, outline, and paint. Now, I took this table from my student's Ph.D. thesis to show you. What I'm about to tell you is a good example of how not every faculty member agrees with their Ph.D. student, but at some point when they've been with you longer than their own children, they want to get you out the door. And they're like, whatever, just write it up and get out, just graduate. And so what you're seeing is ground truth is using those carefully labeled images, how well all the neural nets performed. Now, let's just stop there. Let's look at ground truth. This means that roughly that 47% of the images were labeled accurately. 59%, 65, 65, 67. Does that sound good or does that sound bad? That's pretty bad. Kind of concerning. That's the best. And by the way, I do a lot of expert consulting on similar issues, and that is correct. That is how they perform in the real world. I mean, we're saying 60% somewhere in there, good enough. Like I actually draw a line for my papers that I publish. You have to hit at least 80% for me to say that that's decent, which by the way is still really bad. That's still 1 out of 5 times you got a failure. But okay, so this is what the real world is doing. Maybe. I mean, that's as good as it gets. And then you can start to see below that all the other performances are quite bad. I mean, you're better off flipping a coin in most circumstances. And then my student, he's the one that bolded the draw paint line. He's like, yes! Yes! I've got such good results. These are so great. Everyone should use paint. That's what they didn't know. That's what they should be doing. And then this is me, head on the blackboard. I'm like, I'm not getting through. I'm not getting through to these students. It's all terrible. It's all bad. I'm moving to the Isle of Man to get away from all of this. Okay, so, I mean, that's just the beginning of the story, right? So this is bad all around. And so, by the way, this is why you see so many problems with computer vision in the real world, because it's terrible. So then, we're like, okay, instead of quitting and moving to a place with no technology, is there a way that I can fix this problem? Like, can we address what's really happening? So then what we noticed in a lot of images, you can see here that in the child with the hat and in the pictures of the leaves, that whether you're a human, and you can actually use some auto-annotators to do this, but the auto-annotators are generally worse than humans. But almost in all cases, because we're lazy, it's easy to cut across pieces of an image that are just too much of a pain in the butt to go. Like, to go into the hat, you'd have to go in and around and then up. It's just so much easier just to draw that line across. And indeed, if you actually look at the trees, it would be a nightmare. It would take you forever to kind of annotate what's happening with the trees and the leaves. So people just kind of cut across the top. This is a real-world problem happening every day in all of those warehouses of people. And so we started to look at this, and we're wondering, like, how much of this lazy labeling, what we call corner cutting, how much of this is causing a problem? And then on the left-hand side, I'm showing you, again, that model performance is on the y-axis, and on the x-axis, we're looking at what if we change the error rate just in general. We've got all these different things, like the error rate is uniformly random, pixel addition, just a uniformly random underlying distribution, blah, 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 blah. And we kind of looked at this because we wanted to see, like, okay, how much as your error rate increases, meaning the error rate inside your data, what kind of model performance? And you can see almost right away, especially if you've got some kind of Gaussian problem going, even uniform, you start to see a big drop-off very quickly. And so one of the real questions is how much error rate is going on in these underlying images? So what we did to look at this then is then we went and we looked and we took all these images and we started looking at concave transforms. The concave transforms are basically trying to represent taking off the appendages, right? Taking off the protrusions, appendages, and we wanted to see, like, as we started to take off the appendages, what would that look like? We also looked at expanding, like, because the question is, sometimes people, they don't just cut things off, they actually maybe will draw a big circle and they actually make an image a little bit bigger than it really is. So we wanted to look at cutting things off, adding things, how did that work? So, yeah, it was, we started to see some real problems. You actually look at what's happening, if you actually look at uniform noise, we had uniform noise, concave noise. The uniform noise is growing, concave noise, cutting out of something. So then when you start to look across the increasing fixed sizes, you start to see, it should jump out in your eyes. The red is causing much more noise. So concave noise is detrimental. And also, unlike the cutting off of appendages, is the under annotation. It's clear that that's a problem, a little bit, but it's smaller than I was surprised at the over annotation, meaning that if you're just sort of sloppy and you're growing an image and you're using the concave noise, that is bad, way worse than we anticipated. And so this is a good example of sometimes, first of all, it's good, and I would have missed the over annotation. That's the one thing that my student did right. I was just thinking we would look at the under annotation, the cutting off. He was the one that looked at the over annotation. So sometimes your students are good after all, and they help you learn. And then the question then becomes, what do we do about this? So, and does this affect what's happening with hallucinations? So that is actually where I am now in my research with this project. So we're actually now going to look at this was just a fake world, meaning we took a data set and then we expanded, contracted. Now we're actually relabeling everything with the expansions, contractions, and we're going to run in the real world to see how that works. But then the question becomes, we can see, though, there is a failure mode with the under annotations, but a bigger failure mode is the over annotations. And is this something that regulators could and should look at then? If, for example, you're working at the Ministry of Transport, should you be asking the car companies to show us the quality of their annotations and to what degree of over annotations? Ministry of Defense, same thing. If you're going to start flinging weapons through the air with AI and then with computer vision in them, you probably need to understand the nature of the database underneath and what's happening. So that kind of leads me to my second to last slide, which is, you've got to start thinking about the performance of computer vision systems. And I haven't even touched on the planning and actuation. There are problems there as well, but you can't even get to the planning and actuation problems until you get the perception problems figured out. In this graph that I'm showing you here, what I've done is I've shown you, where are the technologies that you should be caring most about? Like if you're a regulator, or even if you're an academic and you're looking for an interesting problem that's really relevant and important, where should you be focusing your work? On this x-axis is determinism versus non-determinism. Y-axis is low safety criticality, high safety criticality. You're going to need to focus in that upper right corner. And what do you see up there? Surgical and computer vision, generative AI and weapons, any AI in vehicles, LLM-based 9/11 chatbots. It's a thing. I'm just shocked that I have to say this, that in my own county in the United States, the county was like, we love AI so much that we're going to turn over 911, your 999, I think, the 999 call center to a bunch of AI. And then I went crazy. I was all over social media, writing letters. If you think I'm mean to the UK government, I was 10 times meaner to my own government. I'm you cannot do this, blah, blah. I will tell you, my wailing and gnashing of teeth did pivot, and they are now only using them for training 9/11 people, 911 people. So it does show you that you can complain and get some effect. Now, I think one of the other problems along with this, though, is this problem of these technology readiness levels on the right. So in America, we have 9 technology readiness levels. They go from 1 to 9. The laboratory, that's like academia stays on 1 through 3. Companies who are deploying technologies are 7, 8, 9. But what's happening in America is AI is skipping 4, 5, and 6. AI is going straight from some basic lab research context to being deployed. And now, look, if you haven't played around with a chatbot at all, then, if you have, then you know. They're terrible, they hallucinate, they don't get things right, you have to pay attention to them. You better not be using them to write papers with references, because 100% of the time those references are going to be hallucinated, and then you're going to be in trouble. And if you're in my class and I catch you having a hallucinated reference, it's an F. Right? So you just got to sit on top of these things all the time. And one of the problems, and this goes back to what does regulation need to do? I think both academia and regulation, academia needs to expand to levels 4, 5, and 6. We need to do more looking at, okay, then what does that look like to do tech maturation, especially because Gen AI, for example, was not developed in academia at all. So it never went through any tech maturation processes. Well, maybe we as academics need to expand our efforts, and regulators need to reach down and say, we need to look more at what was happening in that tech maturation stage, because it's failing a lot in the tech deployment stage. Last slide. So going from research to policy, when you have somebody's ears, in America, we teach our kids how to do the elevator speech. For sure, for sure, for sure. You need to be able to say, not just in 5 minutes or less, 1 minute or less. I had John McCain's ear for about 1 minute. We were standing in line to get on an airplane together. And for some reason, I was in first class. They must have upgraded me, because this is not a normal. And blah, 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 blah. He got me to his daughter, who is actually big in media, and that helped me make some connections right away. You need to be able to talk about your research in 1 minute or less make sure that people understand how critical it is. Pictures. I had hardly any words. I actually had way more words on this slide, because this was more of an academic presentation. When I talk to regular people, not academics, I try to use no words. And lots of pictures, because it makes people remember. You've got to give people context. You can't just do your research in a vacuum anymore. That used to be okay in the days of yesteryear, but it's just not. It's not in the world of competition for funding, hard economic times. You've got to make sure that people understand why it matters in their lives. And your solutions need to be simple, straightforward. If you have to get down into if you have to start saying, well, let me tell you about a Gaussian distribution, I would never say the words Gaussian distribution ever outside of an academic campus, right? You're going to lose people, right? So you have to learn what the right language is to speak. I've been successful because I'm passionate. And you need a brand. I hate even saying this. You hate hearing it, but it's the way it is. I'm lucky because I have a brand. I have a brand of being the former fighter pilot who is a curmudgeon. She complains about everything. She hates everything. She speaks truth to power. And despite the fact that I am a well-known international curmudgeon, people do call me because they want to know. When they want to write the right answer, they call me. That means a lot of people don't call me because they don't want to hear the truth, right? So I'm okay with you having a brand that may be like, well, maybe I'm a little bit more slippery on the truth. It's your thing, it's your brand. But you need to get a brand so that people understand what it is that you stand for. What do you do research in? Yesterday I saw lots of really great projects. You want to do robot navigation, then you say, that's my brand. That's what I'm into. I am the best at that thing. And if you're passionate about that thing, you will actually be more successful in the world, because people are attracted to passion, and they're attracted to understanding, meaning like they know who you are, they know what you're going to give them, and you will have people keep coming back to you because they appreciate what you're all about. All right, now I know that we're kind of pressed for time, so with that, I'll end so we have a few minutes for questions.
Okay,
Okay, thanks very much, Missy, for absolutely fantastic talk. So we'll go about 5-10 minutes or so for questions from anybody in the audience.
Hi, that was brilliant, really interesting. So traditionally, in our view, often is that the US sort of regulates after disaster, whereas Europe, we've got to be careful whether we count ourselves as Europe, as you can imagine, but Europe does a precautionary principle sort of regulation, whereas it looks what could happen and regulates against. In this case, which side do you think's right? Should it be wait for things to go bang and then regulate, or should it be regulate before things go bang?
Well, I mean, no, honestly, you've got the best of both worlds. It pays to be number two sometimes. Like, I mean, we are basically doing tech maturation for you in America that you do not have to pay for, right? The self-driving cars, I mean, you know, they've got serious failure modes that we didn't really realize until, you know, the last couple of years. Waymo is now going to roll into town somewhere in the UK. I'm strongly advocating that they come to Manchester. I think it would be good for them to be here. I don't think you should change your approach when it comes to safety critical AI. I might, I do think that there's a point for trade-off, but I actually sat with a bunch of regulators last week in London. I have yet to see any British regulator propose something to me that I thought was unreasonable. So I do think that, you know, I'm sure that there are other venues outside of safety critical AI where maybe you guys are a little heavy-handed. I don't know. But from what I've seen, I haven't, I think maybe your cautious approach in today's world is actually benefiting you, largely because America took the other approach and we have shown what the problems are. So, I do think that these are kind of an interrelated. So maybe you shouldn't see your system as independent of ours, right? Maybe they're connected. Wow, that's one question.
So computer vision's terrible, and then you're making that means that we can never do. AI can't magically fix it if the input is rubbish, right? So does that mean it's always flawed? Is that always going to be the human backstop? What's the best place to look to try and improve that? Do you go for the computer vision, or do you go for something more intelligent?
Right. So I flew through this very fast. So computer vision is just one sensor in a self-driving car, other than Tesla. That is all Teslas have, and they say that is all they will ever have. That is not possible. Waymo has been more successful because they have a LiDAR, because they have radar, because they have something that we call sensor fusion, right? So we take all the signals, we get a combined world model, and then the car can execute on that. That's been good, but not great, and that's because, for example, LiDAR does not work well in misty rain conditions. Has not been a problem in Texas, Arizona, will be a problem in, it is sometimes a problem in San Francisco, but definitely going to be a problem here, which is why I think it's a good idea for them to come do their pilot operations here, because this is really going to challenge them in a way that I think, but it's not going to kill somebody in London. If they were to roll out in London, someone would die, because London is just chaos among chaos. So I do think that it is possible with sensor fusion, the creation of the world model, but from a research perspective, I have to tell you, that combination is good, it's not great, it's not enough. There is a gap there. Sensor improvement, I saw some great neuromorphic camera work yesterday. Maybe that could be embedded. Like, there's got to be something else, or you will get slow speed self-driving cars. They have been okay, but in America, self-driving cars cannot operate on the highway because the time of processing and the time of reaction, it's just not conducive to that environment yet. And so I don't know if we'll ever get there unless we do have some new breakthrough.
Any other questions at all?
So what is it the UK government's
I mean, it is a similar problem everywhere. I just think it's been particularly acute. It's the Lords, the House of Commons people, ministers, the President King, shooting their mouths off about AI, where it's clear when they open their mouths and they say something about AI, it's like a knife through my heart because it's just wrong, and it's like dumb wrong. And so I have just been advocating strongly. By the way, we have this in America as well, although I have managed to get to a bunch of CEOs. Like I'm helping shut some people up as much as I can. I was with the World Economic Forum for a couple of years, and all I did for a couple of years was meet with CEOs and just bash them around the ears. Don't say stupid things like that. But I think that one of the reasons it's particularly acute in the UK is that there's all this discussion now about the FANG companies, Amazon, Google, whatnot, coming in and developing your data centers. So I think it's a particularly acute running around saying AI is amazing or AI is going to kill us all, which if you actually think about it, doesn't make sense coming from the same person, but that's what's happening. And then, but the backstory is there's a lot of money being promised to your country in the development of data centers if you will only agree to put ChatGPT in all your schools, to make sure all your government employees use ChatGPT. Companies in America are starting to ban the use of large language models altogether. Other companies are starting to ban them for code generation because the code is both terrible and it comes with, because the Chinese and the Russians have figured out that how to insert security flaws. So people in America are starting to, we are past the peak of the bubble, coming down to say, wow, it may be good if I need to create a copyright-free image, but beyond that, like, what is this technology good for that's not going to put me at serious risk? The UK is kind of behind us, which I think is typical technology. You guys are coming. I'm not sure you're quite up on the peak yet. Hopefully you're near peak. I'm trying to cause you to go over the peak. Like Missy Cummings was in London. I can promise you Waymo is so mad when they find out that I've been over here. They're going to be like, because we need to get past this overinflated peak of expectations, and we need to get you guys coming down the other side. This is the Gartner hype cycle, right? If we can get you to come down the other side, then what happens is you'll eventually get to the peak, that plateau of utility, right? But the more you get up there, the more you raise the public's expectations, then inevitably when you come down the other side, the public is going to realize they've been duped. They are going to hate academia. They're going to hate the government. And that is what is happening in America right now. So again, we're leading you, and now no one believes in academia, and everyone despises the government because, and not only, but a big factor of that is the increased expectation around AI. You're like, wow, that was really too sad for the morning. Do we have time for one more question, Patrick? Yeah.
Thanks, Missy. I thought that the sort of bubbles, the circles on your last slide, the size of them were really, really interesting. How important do you think it is that researchers have the confidence to engage with media and that sort of public speaking side, which isn't a superpower of many researchers? Yeah. And do you think it should be part of every PhD or every degree?
Absolutely. I actually, I went to the Top Gun school, and they actually have a school inside of the Top Gun school. Surprisingly, they have a school for public speaking. So I'm lucky. I had formal training. So yes, we need to get formal training. Public speaking is also a perishable skill. You need to keep doing it all the time to make it easy on you. Like, I prepare zero for presentations anymore, whereas in the old days, you'd spend hours getting ready for a presentation. So yes, some schools do a better job. Some schools make it mandatory. I would actually say I'm not as worried about the PhD students as much as I am, because, by the way, if they're making TikTok videos, they're on brand. It is the older faculty who are not so TikTok savvy or Instagram savvy. I do find that getting people to understand how to engage the media it's its own area. right? And some university communications departments do a great job. Some don't. So I would actually say, you know, the feedback should be if your comms department is not actively participating, then you need to, that needs to change.
Okay, so I think in the interest of time, there's a lot of comments about to start. I'd like everybody to find this